Good afternoon, this is Dr. Pradhan here. Welcome to NPTEL project on econometric modeling. So, today we will cover penal data modeling. So, in the last couple of lectures we have discussed dummy variable modeling, that to dummy dependent and dummy independent, again a single dummy and multiple dummy, and also interactive effect. So, many ways we have discussed, means in this dummy independent, there is a one dependent case, multiple dependent case, and its interactive case. Similarly, in the dummy dependency case, so we have discussed linear probability model, binary choice models, logit model and probit models, and we have also discussed various differences between all these models. In fact, we have not discussed a practical problem because of lack of time. In the meantime, we will discuss the same thing in the penal data model, because it is too much integrated with the penal data model, and in that case we will discuss something application, and we will touch the dummy variable modeling also. So once we will discuss the penal data model, then obviously we can also get touch with the dummy variable modeling. So, because it is means without knowing dummy modeling, it is very difficult to handle penal data models, because it is the basic means penal data for understanding the penal data, dummy variable modeling is essential. So, until unless you have complete knowledge on dummy variable modeling, it is very difficult to understand the penal data modeling. So, last couple of lectures we have already briefed about the dummy variable modeling, that to dummy dependency and dummy dependent variable and dummy independent variable. So, today we will discuss the penal data model, and we will also cover how the dummy can be used in the real regression analysis, and also highlight the issue of dummies. So, before we go to penal data modeling, so first of all, what is penal data? So, in the last last few lectures, or you can say from the beginning, so we have discussed the data analysis only. So, that too you talk about bivariate or trivariate or univariate or whatever may be the case, or you can say multivariate, or even if the problem aspects like multicollinearity, heteroscedasticity, autocorrelation, dummy variable modeling, etc. everywhere. So, every problem is associated with data. Without having data, it is very difficult to understand particular problems, or you cannot apply it. Means so far as application is concerned, so without having a particular setup of data, it is very difficult to understand. It is a so first of all, what is data? Data means it is actually collection of information. So, now once you have some information, then that information may be very quantitative in nature, may be very qualitative in nature, may be in both. Okay, so that we have very much clearly identify, or you can say categorize in the case of dummy variable modeling. So, up to dummy variable modeling, we usually handle the quantitative form of data, but during the dummy variable modeling time, so we have discussed both the quantitative aspect of data and qualitative aspect of data. So, here we will discuss same data modeling, but with a different setup and different structures. So, basically data means collection of informations. So, collection of information with respect to what? So, that is how the basic data setup is started. So, a collection of information with respect to three aspects: time aspect, cross sectional, that is individual unit aspects, and also integration of both. So, that means data can be collected with respect to individual observation, or that is what we call it cross sectional unit. Data can be used under time series analysis, and data can be collected under both the heads. Okay, so like this penal data. So, first of all we will discuss what is penal data. Okay, first of all we will discuss what is penal data. So, first we start with the data classification, then we will go to the penal data. So, data is basically divided into, or I can call it four different angles we can classify. One is called as a cross sectional, then time series, then pool data, then penal data. Okay. So, cross sectional means data available with different cross sectional unit, that is called as a cross sectional data. So, this is usually indicate with I subscript. Then time series means data is collected over a period of time, that is usually represented by subscript T is T. Yes, pool data means it is a combination of both cross sectional and time, just we are pulling cross sectional and time series data. So, this is IT representations, and penal data is also pulling, or you can say clubbing all these cross sectional and time series units, it is also IT, but between pool data and penal data there is a difference. So, what is penal data? Penal data basically means data collected in cross section, but they are observed periodically. So, means data can be collected in a particular individual or cross sectional unit, but can be observed periodically, means with respect to time observation. So, that is what it is called as a penal data setup. Or when pool data is concerned, so we are just pulling time series cross section time series and cross sectional data, but we are not discussing the inside pictures in between clubbing the time series and cross sectional data. For instance, so when we will club time series with cross sectional unit with time series units, then definitely there is some kind of error in between. So, the variation will start, and that variation will affect the individual parameters as well as the error component. So, as a result, so there is some kind of problem is happen, means it can be raised there to handle the pool data. So, basically the whether you will use purely time series data, cross sectional data, or pool data or penal data, depending it is absolutely depend on your objective specification. Okay, suppose if your objective is not to study about the variation of individual aspect and time series aspect, then obviously you go ahead with the pool data. Pool data is just like a simple regression analysis, like cross sectional observations and time series observation. It is just you are clubbing. So, that means data features are not there, just you are clubbing and increasing the sample size, that is all. But the moment you will use pool data, there is lots of limitation associated with the calculation involvement. So, now basically cross sectional we will indicate I observation, time series T observation, and pool data clubbing of time series and cross sectional unit, and penal data it is also cross clubbing of cross sectional and time series data, and also in the same times we are studying the variation of individual units, and also individual, or you can say group units, and also time components. Okay. So, now for this is I T or okay, this is subscript, but if you say for a particular variable, then it becomes xi, then xt, then xit, then this is xit. Okay. So, that means here, so there is a means, so we are targeting the variation of individual intercept terms, and also we are targeting the time series term. Okay, time series effect. So, that is how it is called as a penal data. That means, penal data is a broad concept, and it is a complex problem. It is most practical, more feasible in the case of handling the you can say regression modeling or econometric modeling. So, now what is the speciality of penal data modeling? So, that means we can solve a particular problem through cross sectional analysis, we can solve the time series analysis, we can solve through pool data analysis. So, now the question is, what is this penal data? If everything is observed very easily, then why will you go for penal data? Because yes, pool data is a part of the penal data, but pool data we are not just considering the problem aspects of pulling cross sectional and time series, just we are pulling and you are increasing the sample size. So, the moment you are increasing the sample size, so within that integration there are certain problems which we will take care through intercept concept, and you can say time series concept, that means cross sectional issues and time series issues. So, now what is the, first of all, what is the advantage, or what are the learning lesson will we receive from the handling penal data modeling? First of all, there are basically three specific factors through which we like to enter penal data modeling, or we like to learn penal data modeling. So, first thing, so we like to observe a particular variable with respect to its individual units and with respect to its periodical issue, that is means time series observation. For instance, let us say there are 3 airlines, okay, 1, 2, 3, okay. So, now we like to know what is their production capacity, or you can say cost involvement with respect to 3 airlines with 3 different time periods, or you can say 5 different time periods. So, that means I is here represented as a cross sectional units. I stands from 1 to 3 like this. I stands for 3 cross airlines, then I will put 1 2 3, and for 5 different ways time periods we will take 1 2 3 4 5. Okay. So, this is how we will represent. So, that means, so if we will club, then for panel data, we will club these two. So, this is I into T. So, this is IT observations. Okay. So, this is IT observation. So, that means we will have a 15 observation in this particular setup. So, that means if you will go by cross sectional analysis, then you have only 3 observation. If you will go by time series analysis, then you have only a 5 observation. So, now when we will club all these two, then you will get 15 observation. That means in the very beginning we have mentioned, typically we have highlighted for any specific modeling. So, your sample size should be substantially very high. Higher the sample size, higher is the accuracy of the model, or higher is the feasibility of the model. If the sample size by any chance it is low, or you can say it is go against the system, for instance, where variables are very high, say 10, and number of sample is say 5, then obviously the system itself is inconsistent, you cannot solve the problem. So, if there is a proper means you have to, for a particular model you have to maintain the proper accuracy of sample size or data structures. Without having such clarification or clarity, it is very difficult to handle the or difficult to go for estimation. So, before going to estimate a particular models, your sample size and model specification must be very feasible one. If the system is inconsistent, then obviously the estimation will go other way around. That means, whatever estimation results you will get, all the estimators will go against the blue theorem. So, that is how these are all means you must be very careful, and you must integrate in the econometric modeling systems. All right. So, in this panel data modeling, so we are just observing data or you are collecting data at a cross sectional level and observing the same in periodically. So, that means with respect to time sense. So, that is how it is very interesting. So, that means one of the special advantage of panel data is it will observe a particular variable with respect to its cross sectional dimension, and it is time series dimension. That means, it is within the effect and between the effect. Okay. So, this is how we have to observe. For instance, I equal to 1 2 3 means there are 3 different airlines, then 5 different time periods. So, now for I equal to 1, so first airlines we like to know what is its impact over the years. Okay. What is its cost involvement over the years. Okay. Similarly, like this. Okay. You see here. So, if you put I 1 2 3 here, then T 1 2 3 4 5. So, that means here you will have observation, here we will have observation. So, now I can go this way, I can go this way. Okay. So, this is how it is called as a within effect and between effect. So, this is one of the special advantage we will observe in the case of panel data setting. Okay. Second observation is that it will obviously by default it will increase the sample size. If you go by only cross sectional analysis, or if you will go by time series analysis, then the sample size will be very small, but if you will integrate with proper panel setup, then obviously it will give you a huge sample size, and that is more practical and more reliable for the econometric modeling. So, this is the second advantage we have to use for panel data setting. Okay. So, third advantage that we need special treatment. Okay. We need special treatment for handling the panel data analysis, because the moment you will club I with T, in between there is lots of problems, as variation may be it can be raised. So, that is how you have to be very careful how you have to handle all these problems before integrating cross sectional observation time. So, these are the 3 major issues we have to you have to know before you enter it in the panel data modeling. Okay. So, now what is all about this panel data setting? All right. Generally, before I go to this particular setup, so I will briefly highlight what is all about the modeling structure under this panel data modeling. So, we have already mentioned. So, the data is specifically divided into 3 parts: time cross sectional, time series and penal data, okay. So penal data, pool data is in fact same, but there is means typically when we will handling penal data, then there is no issue of the pooling concept. So it will come in between automatically, okay. So that means, so we will have three different structures: cross sectional, time series and penal data. So obviously there is a pool data, so we will go to that aspect separately. So when we will discuss about the separate aspects of penal data, that times pool data has a image, or you can say has an impact. Right now for comparing cross sectional, time series with pool, then obviously pool or penal is same group, okay. So if we will study its variations of individual aspects and time series aspect, then obviously it will be penal data, otherwise it is just pool data. So then obviously there are three forms of the data. So time series, cross sectional and the integration of time series cross section. So that is how it is called as a penal data. So so there are accordingly there may be three models we can develop. For cross sectional, the model will be means if the system will be with respect to y and x, then we can write like this: y equal to beta 0 plus beta 1 x1 I, okay, plus u, okay, plus ui. So here I equal to 1 to up to n. So this is how its cross sectional modeling. So the system will be here y upon x1, okay. So this system will be here y upon x1, and we are setting with a cross sectional observations, okay. So keeping time remain constant, okay. That means we are not using any time aspect. So we are just integrating cross sectional items only. So okay. So for time series, the model will be, instead of yi we will put yt. So which is nothing but beta 0 plus beta 1 x1 t plus ut, okay, t equal to 1 to up to capital T. So this is how the time series setup all about, okay. So that means when we will set the time series, so the variation will start with respect to time, keeping a cross sectional unit remain constant. So we are not bothering the cross sectional unit. So just like for 3 airlines, we are just targeting I equal to 1 or I equal to 2 or I equal to 3. Then we, for each particular component, say I equal to 1, then we have to see what is the variations or what is the structure within that particular system. When t equal to 1, t equal to 2, t equal to 3, t equal to 4, t equal to 5, okay. So similarly for I2, I3 we can analyze, but there is no connection between I1 to I2 and I1 to I3. So that is what the time series is all about. Similarly in the case of cross sectional, so we are discussing row wise, so what is the variations I1, I2, I3, but we are not discussing what is the variation of I equal to 1, 2, 3 with respect to T1, T2, T3, T4, T5, okay. So this is how it is constant. So we are either using I equal to 1 to 3 with respect to T equal to 1, or I with respect to 1 to 3, and that has to integrate with t equal to 2 only. Then the impact means the variation of I 1 to 3 with respect to t equal to 3, like this. That means it a particular year. So we are discussing the cross sectional variations or cross sectional observation. So this is how time series modeling all about. Pure time series modeling, this is pure cross sectional modeling. So now then there is called as a penal data modeling. So in the case of penal data modeling, so our model will be integration of it, okay. So y it equal to beta 0 plus beta 1 x1 it, okay, plus uit, okay. Here here I equal to 1 to n and t equal to 1 to t, okay, and total sample is n into t. So here total sample is t, and here total sample size is n, okay. So total sample size is at n for cross sectional modeling, total sample is capital T for time series modeling, and for penal data modeling the total sample size is nt, okay. So this is how the penal data this is the basic of this penal data structures, okay. So now how do I represent this penal data setup? So let me highlight here the structure of penal data, okay. So generally I have mentioned how you have to set up this penal data structures. So for instance I have already mentioned for I, and I will put it here t, then let us say the variable say output, then cost, then let us say fuel amount, loading capacity, Okay, so these are the observations. So we have taken I equal to 1 to 3 and we have taken 1 to 5. So then how will we represent the sample setup? So this is very interesting. So I is there, t is there. So we are integrating it. Then how is the sample setup? So let's see here. So for this is for airline, I for airline, and t for time, or it is airwise analysis. Okay, so then output with respect to T and I, cost with respect to T and I, fuel with respect to T and I, and loading is with respect to T and I. Okay, so now how will we set up this one? So let's say I equal to 1, then it is 1 1 1 1 1. So T equal to 1 2 3 4 5. So 1 2 3 4 5. Okay, so this is one observation. So accordingly it will be analyzed. Okay, so keeping I equal to 1, t is varying here. So okay, keeping I equal to 1, t is varying here. So now when I equal to 2, let us say 2 2 2 2 2, then obviously t equal to 1 2 3 4 5. So accordingly it has to be filled up. Okay, it has to be filled up. Then similarly, so when I equal to 3, then 3 3 3 3 3, then 1 2 3 4 5. Okay, so this is how proceeds. Okay, so similarly when I equal to 4, I equal to 5, then obviously, so now here we are getting 5 5 5, then 5 raised 5. So if you will add, then you will get more number of observations. Okay, so this is how this system will operate. So that means this is how the structure of the panel data modeling. Okay, so now with the basic framework of panel data setup, so we will discuss the the accurate estimation process of panel data modeling. So how do I if we start with this panel data modeling? Let's see here. So now panel data specifically, panel data modeling specifically has a 3 different angles. Okay, so one is called as a pool data angles, then another is called as a fixed effect models. Fixed is a pool data, it's pool data model, then it is fixed effect model, then there is called as a random effect models. So there is another model called as a random effect model. So that means we have specifically highlighted 4 different structure of data setup: time series, cross sectional, then pool and panel. So far as the panel data is concerned, so we are talking about the pool component and the panel component. So we are not very much strict about the time series, individual time series or individual cross sectional. So now here we are just pooling and we are observing the issues. So now for pool data modeling, so the sample setup is we can use simply ordinary least square method. So far as the methodology is concerned, so means you see here. So our aim is to have the data, whether it is a time series data or cross sectional data, or you can say panel data or pool data. So now once you have a data, then obviously we have the variable information, because without having what is the data analysis structure? Data analysis is the middle process of the econometric modeling. So initially we will start with the theory, then you design a problem, then with respect to problem we have to specify objectives, and with respect to objectives we have to specify hypothesis, then with respect to objective hypothesis we have to set the model. Then once you will set the model, that means it is a mathematical form of the model. Since hypothesis is there, so accordingly it will be transferred to statistical form of the model. So once you have the statistical form model, for instance, let us say there are variables say y and x. So now this is y as simply as a function of x, like this. Let us say y is simply function of x. Okay, so now this is implicit format. So I will call it this is purely a mathematical model. So now before you go before you proceed further, so you have to put this model in explicit format. So far as a correct specification must be concerned. For instance, in the models here, so we have described, okay, so this particular models, so we have described the cross sectional effect, time series effect, and multi panel data modeling system. So now when there is a mathematical form of the model, then error must not be there. Then obviously we have to just we have to put the explicit format, just y equal to alpha plus beta x. Okay. So, then similarly we have to apply I subscript or T subscript, then also IT subscript. So, that is not a problem headache. So, that means you have to go with the objective hypothesis, then mathematical form of the model, then you have to transfer into statistical form of the model by introducing the artificial error term, and finally we have to minimize the error term to get the best fitted model. Okay. So, this is how the usual procedure all about. Okay. So, now when you fit the statistical form of the model, then obviously you need to estimate the statistical form of the model. So, for that you need information or data. So, with the help of data or information, you have to process or estimate the model to get the means we to understand the exact nature of the relationship among the variables. Okay. So, for that we need to have information and its process. So, when you need to have information process, then obviously the system will be very okay, or system will be very efficient if the information is exclusively very high. Okay. But most of the problems in the real life situation, it cannot be possible to have a huge sample size. So, what you have to do? So, since it has a problem or constant for econometric modeling, so econometrician has developed the concept of penal data, so that the cross sectional and time series can be clubbed, and that can be used for econometric modeling to verify particular statistical models. So, the way we will integrate, then obviously that structure is called as a penal data modeling. So, when we will integrate, then there are several serious issues are coming in. So, that issues we have to take care very carefully. Okay. So, now accordingly, so when we will club all these variables, means data with means that is with respect to cross sectional and time series, then obviously you will find there are two forms of models. So, one is called as a pool data models, and another is called as a pure penal data model. So, when there is a pure penal data model, so this pure penal data model is further divided into two aspects, that is called as a fixed effect model and random effect model. So, I will now highlight what is fixed effect model and random effect model. So, so far as OLS is concerned, pool data model OLS is concerned, this particular structure is just it is just pull the cross sectional and time series data, okay, but do not consider any you should not consider any aspect of cross sectional and time series behavior. So, that means please you do not consider, or there is no consideration of, do not consider the cross individual and time behavior, individual, that is cross sectional and time behavior. Okay, time behaviors. So, that means if there is no such consideration of individual and time behavior, then you just pull the data, and as usual the application of OLS in the case of cross sectional modeling and time series modeling separately. So, you can also plot this OLS, means apply this OLS to this pool data analysis. So, it is very simple, very easy, very reliable, but there is inside there is lots of complexity. So, that complexity can be evaluated, or you can say investigated through the penal data modeling, that too fixed effect model and random effect model. So, now in the case of fixed effect models, so there are what is there. So, here means we are just pulling, first condition is satisfied, pulling cross sectional and time series data, and in the same times you have means you are considering the time effects and individual effects, time effects, we are considering the time effects and individual effects on the intercept, okay. So, that means so when you are using penal data model, so you have means we have three different formats. So, one is called as a pool data model, then fixed effective model and random effect model. Pool data model, in the case of pool data model, we are just pulling the data without having any connection with the individual aspect and time series aspect. Okay. And for that reason OLS is the technique which is usually used to estimate that particular model and to have the parameters. Okay. But when you will go for fixed effect model, then that times we are just pulling the cross sectional and time series data, but in the same times we are observing the time series effect and individual effect on the panel data. So, that means this is in the case of fixed effect model. So, the individual impact and time series impact is studied through intercept. Okay. So, there is a term called as an intercept. Okay. We have set y equal to alpha plus beta x plus UIT. So, alpha is the component where we will make the variations. So, we will apply the variation with respect to individual aspect and time series aspect with the intercept concept. Okay. So, like this when we will set a simple models yi equal to alpha yit equal to alpha plus beta xit plus uit. Okay. So, now when we study the variation or effect of individual aspect or time series aspect with respect to intercept, that to target here only. So, that means it may be alpha I or it may be alpha t. So, this is how we have to observe, or separately you can say I will create another parameter say alpha I and you can say gamma t. So, this is how the effect of panel data can be observed. So, that means when we are observing the variation of individual aspect and time series aspect on intercept, then it is called as a fixed effect models. Okay. But in the case of random effect model is something different. You remember you know here means we can make a guess here that the moment you will we have the variational impact on this intercept. That means when time series variation and cross sectional variation is observing with the respect to intercept, then obviously that impact will directly go to or indirectly go to the error component. So, as a result error cannot be constant. So, error will vary. So, that means you see how it is connected. So, first pool data there is no connection with the intercept. So, intercept is remain constant. Okay. So, now when means we are artificially keeping constant the time impact and cross sectional, because time is dynamic and also cross sectional is dynamic. That means it is not a static I, just like I equal to 1 or I equal to 2 or t equal to 1 or t equal to 2. Here I varies and t also varies. So, that means the moment it will vary, then there is lots of variation or you can say further impact. So, now that further impact is observed through error intercept, and that the moment you will observe that variation in the intercept, that is called the fixed effect model. So, when we apply that variation on intercept and that to fixed effect model, and obviously that further impact will go to the error terms, and when we will observing the error variance with respect to time dimension and cross sectional dimension, then it is called as a random effect model. Okay. So, that means the usual procedure is you will go with pool data, then fixed effect model and random effect model, but generally fixed effect model and random effect model are the two you can say pure panel data models. Pool data is not a pure panel data model, because we are not targeting any variation of time series and cross sectional observation. So, here we are studying we are increasing sample size, that is very handy for the estimation process. In the same times we are studying the variations with respect to cross sectional observation and time series observation. Okay. So, in the case of random effect models, so we are pulling against. So, we are pulling cross sectional and time series data and consider the time effects, consider the time effect and you can say cross sectional effect on the error terms, you see here. So, now we initially we have this much of connection. Okay. What we have learned from the econometric modeling, whether it is bivariate, trivariate or multivariate. So, ultimately target is y and x, okay, dependent to independent, but when we will target dependent to independent, that times. So, there are certain there may be certain problems. So, one such problem is the having data sample size. Okay. So, if the sample size is low, then you cannot go for estimation. So, to solve that particular problem, so we are applying, or we econometrists are usually use the concept called as a penal data. So, the moment they will use the penal data, it will increase the sample size, but in the same times there is some additional problem. So, that too means additional problems that may be observed with intercept, and with it can be observed through error term, because between y and xt there is other terms are left, alpha and yt. So, yit. So, that means the connection will go to this side and connection will go to this side. So, if it will come to this side, so this is called as a fixed effect model, and if this will go to this side, it is called as a random effect models. Okay. So, now that means it is the dummy variable which make the difference between the fixed effect model and random effect model. The dummy variable which we have discussed in the last couple of lectures. Here the dummy means it is the dummy independent clusters. So, that means here we are using dummy with respect to cross sectional observation, and here we are using dummy with respect to time series observation. So, that means we are very much interested to know as a cross sectional point of view which particular component is more efficient, more effective, more productive, and on the other side with respect to time we like to know which particular year is more efficient, more productive, and more stable one. So, this is how the entire theme is all about. So, means that is the entire structure of penal data modeling. So, now we will briefly highlight the exact difference of fixed effect model and random effect, because pool data once you will go for pure penal data modeling, that time pool data is not in your territory. So, it is somewhat out of this territory, because we ultimately together means we are very much interested when we will go for pulling the cross sectional time series data, then what are the other impacts we will get. Obviously, the advantage is that we have more and more sample size, and we will get the means our estimated model will be more practical, more feasible, and in the same times the parameters will follow the blue theorem. But in the same times there is some times of additional problems. That means additional problem means this intercept will not constant, and error component will not constant. But you remember when we are handling the direct direct Wallace technique. So, that times we are assuming that the intercept is constant, then error term is constant, and also the slope is constant. So, okay. So, there are three forms altogether. So, there are altogether three forms to observe this penal data settings. Okay. So, that means you see here. So, when we will go for penal data settings, so we will together find means 4 different setups together. In fact, we have already mentioned here 3 different setups. So, within 3 different setup, 2 different setup is more practical and more feasible, but above all there are 4 different ways we have to represent the penal data settings. So, what are these structures you see here? This penal data, this penal data modeling is like this. So, it has 4 different connections. Okay. So, 1, 2, 3 and 4. Okay. So, this is how 1, 2, 3, 4. Okay. So, what is the penal data all about? So, penal data will be general format is like this: yit equal to alpha I plus beta xit plus uit. So, this is how the usual penal data is represented. Or when we will observe time series component, then obviously yit equal to alpha t plus beta xit plus uit. Okay. So, this is one format. Or sometimes what happens, so we can use the third format. So, yit equal to alpha I plus gamma t, okay, gamma t plus beta xit, okay, plus uit. Okay. So, this is actually complete form of the penal data models. Okay. So, that means here it is the individual impact, it is observed by individual impact, and it is observed by time series impact, and it is observed both the cases. This is error component. Okay. So, this is as usual the independent variable, and this is the dependent variable. So, now you see here sometimes what happens, I am keeping constant and making target on time series, then the model will be like this. Okay. So, now I am keeping this one constant, and if I am targeting this one, then it is called as means it is cross observation of cross sectional only. So that means if we together, then obviously, but in addition to that, then there is a model called as a yi equal to alpha plus beta xi plus ui sorry beta xi plus ui, or we will put yt equal to alpha plus beta xt plus ut. Okay. So this is another format. Okay. So that means this is 1, this is 2, this is 3, this is 4. So there are 4 different shapes of the models when we are talking about the panel data modeling. So that means in one case it is just like cross sectional modeling, it is time versus time series modeling. So there is no connection with the time series impact when we are observing cross sectional, and when we are observing time series there is no connection to cross sectional. And the speciality of these two model is that, so here we are assuming the alpha component and means intercept and error component and the slope coefficients are all constant. So that means alpha is a constant, beta is a constant, and error is a constant. It is not so dynamic. Okay. So now, but we can make the system dynamic the way we have discussed, heteroscedasticity issue and the autocorrelation issue, because once you have error term, then you will create additional error terms with respect to time series, with respect to cross sectional. Okay. So if that if that is not your objective, then the model will be very much constant. So that means alpha is constant and slope is intercept is constant, slope is constant, and error term is also somewhat constant. So then that is one set of models. In another set of models, so intercept will vary with respect to cross sectional units, keeping time remain constant, and in other case time will change with respect to different time observations, where cross sectional will be remain constant, and in the and finally both will go together. So means both intercept and means both cross sectional and time series will together, they can vary. Okay. So these are the 4 different shapes of this panel data setting. So let us see here. So now in the first case, slope and slope constant. Okay. So slope constant and intercept vary over individuals. Okay. Over individuals. Okay. So first is slope constant and intercept vary over individuals. Okay. So that means, so out of 4 different situations, we are not discussing this particular aspect, because this is not at all in our boundary of panel data. Okay. So this is purely purely cross sectional aspect, individual cross sectional and individual time series domain. So there is no features of the panel data setting. So that is why we are not bothering about this particular aspect. So now we are discussing all these 3 aspects, then accordingly we will represent various shapes and structure of this panel data modeling. So that means if you have a model and if you are integrating cross sectional and time series, so that means, so altogether we have dependent variable, independent variable, intercept and error term. So that means sometimes we have basically the target is to know the what is the intercept, that is the parameter of intercept, and the parameter of variables, that is the slope coefficient. So we like to know how is the impact on slope and how is the impact on intercept. Okay. So obviously u is ultimately is a variable also. So ultimately u, y, x all are altogether variables. So we are targeting mostly on the parameter side, that is intercept and slope. So accordingly the model can be designed in the means in the case of panel data setting. So in the first case, so slope will be constant. So as usual slope will be constant, then intercept will vary over the individuals. So this is first case. Second case, slope is constant, okay, and intercept varies over individuals and times. Intercept will vary over individuals and time. Okay. This is second aspect of panel data setting. So that means in this first case slope is constant, intercept will vary with individuals only, that is I subscript I only. So here slope is constant and intercept will vary over I and t together. Okay. So, this is another setup. Then slope and intercept will here, slope and intercept, then slope and intercept will vary over individual, will vary over individuals. Okay. Individuals. Okay. So, now here we have discussed slope is a constant in this particular, in this two case slope is a constant. In one case intercept will vary with the individuals and intercept will be vary with the individual and times. In the third case slope is constant and intercept will vary over a slope and intercept, there is no slope constant. So, here slope and intercept will vary over individuals. In the fourth case all will vary simultaneously, all will vary simultaneously. That means is slope and intercept, will vary over individuals and time. Okay. So, this is the fourth case of penal data setting. So, now what we how we will conclude here. So, that means when there is a penal data setting which is which is advanced than the pure cross sectional modeling and pure time series modeling. So, in the penal data setting, so again we have to divide it into two groups. In one group slope is remain constant, then we allow intercept vary with respect to individuals, and another case slope will vary with respect to individuals and times, okay, time periods. So, in both the cases intercept will remain constant. Okay. No, sorry, slope is constant. One case intercept will vary with the individuals, in another case intercept will vary with the individuals and times. Okay. In the third case, third and fourth case, intercept both intercept and slope will vary. One case it will vary with individuals, in another case it will vary with both individuals and times. Okay. So, these are the four different setup of penal data modeling. Okay. So, now we will come to what is the exact estimation process of this penal data modeling. So, there may be different shapes of penal data modeling, like you know something about cross sectional, you know something about time series, you know something about pool data, and you know something the all these cases where intercept slope is constant, intercept will vary with the individuals and vary with the individuals and times. Again slope and intercept both will vary with individuals, keeping time remain constant, and both will vary with respect to individual and times. These are the various structures altogether in the penal data setting, but we specifically highlight two aspects of penal data modeling, that is the impact of fixed effect model and random effect models, and that we will just means in the same times we will just make a difference with respect to pool data setting. So, altogether, so we will discuss three different setups. So, pool data models, okay, pool data model, then penal data model, that to fixed effect model, then penal data model, that to random effect model. So, altogether we will discuss pool data OLS, okay, then fixed effect model, fixed effect model, and third is a random effect model, okay. Third is a random effect model. Okay. So, now you see here, before we going to discuss this these three separately, I like to make some clarification with respect to fixed effect model and random effect models. Although the estimation process or calculation process are completely different from pool data model to a fixed effect model and penal data model. So, in the meantime I am not discussing the details about the calculation procedure of this three models. So, we will discuss this means estimation process in the next class. So, in the meantime I will just clarify few things here with respect to fixed effect model and random effect, because these two are the core model in the panel data settings. Okay. So, generally when we will go when we will make any analysis on panel data modeling, so random effect, either random effect or fixed effect or both has to means have to go together. So, okay. So, it is must when we will the moment we will mention the analysis based on panel data modeling, then obviously there must be some kind of fixed effect model, random effect model, or both models. So, pool data will be come in between. So, okay. So, it is mandatory that you have to know what is the exact structure of panel data, means fixed effect model and random effect models. Okay. So, now I will make a difference here, what is the exact difference between fixed effect model and random effect model. So, let us see here. So, basically panel data modeling in its original form, panel data modeling is looking into two aspects. This is called as a fixed effect models and random effect models. So, let me first highlight what is the modeling difference between these two. Okay. So, the modeling difference between the two is like this. So, here YIT equal to alpha plus mu I plus beta XIT plus UIT. Okay. So, this is how UIT. Okay. So, this is UIT. So, this is fixed effect models. Okay. Then okay, then random effect model will be, so YIT equal to alpha plus mu I. Okay. So, this is, you know, mu I means it is again variation variation on intercepts. Okay. Alpha is again supporting factor to that. All right. So, then this is alpha, then beta XIT plus UIT plus VIT plus UIT plus VIT. Okay. Plus UIT plus VIT. Okay. So, now, so this is fixed effect model and this is random effect models. All right. So, now here in the case of fixed effect models, so the impact will go directly to intercept. Okay. And in the random effect model, the impact will directly go to the error term. So, that is the most technical difference between the a fixed effect model and random effect model. So, in one case the individual variation or time series variations will go to intercept, and if it is separate, then you will put mu I, or you can say any other component, say eta t. Okay. So, this is how, or you can say gamma t. So, this is how one case it will study the individual variation, and in another case it will study the time series variation, but in all the cases it will target the intercept only. Okay. But when we will target the variation on intercept, then obviously the some kind of impact will go to the error component. So, the moment it will go to the error component, then we will study the error observation also. So, in the moment we will study the error observation, then in that case we will assume that the intercept will remain constant. Then what is the impact on error variance when we are making, you know, individual variations and, you know, time series variation. So, when we will target individual variation and time series variation, then obviously it will go to error term. So, that means error term basically, so it has three different segment. So, one segment is the individual segment, then time series segment, and both the segments. So, these are the three different classification of this means error terms, error impact. So, obviously, so technically there is a difference between fixed effect model and random effect model. Sometimes there is confusions because we have not discussed anything about the estimation process, which we will discuss in the next class. So, in the meantime, after, you know, knowing the technical procedure of these two models, you can get to know the exact answer, but always there is a question. So, what per type, which between the two, which particular model is more feasible and which one should be used. So, it depends upon, there are many aspects we have to answer these questions. First thing, when we will go for, you know, fixed effect models, then obviously the parameters are too many. Okay. But when we will go for random means because it is intercepts are changing and obviously time is changing. So, obviously parameters are very high. So, when we will go to random effect model, then the parameters are very less. So, as a result, if that is the case, then obviously fixed to go to the fixed effect model means go to fixed effect model may be better choice or random effect may be better choice, depending upon exactly depending upon the size of sample. So, means exclusively it will depends upon the individual observation and its time series observation. So, with the help of individual observation and time series observation, then we can get to means we can come to a point that means we can decide that which particular model is more effective than others. Means the detail will be discussed in the next class. So, with this we can conclude this session. Thank you very much. Have a nice day.